Right, this first one, hopefully not too much of an issue. The highest common factor of m cubed and m is just m, so that's going to get outside my brackets. Inside, I'm going to have m squared, because m times m squared is m cubed, and 1, just because it's m times 1. Now this next one is an example of the difference of two squares. So that is when you have two square numbers that are subtracted from each other. The most common way you see this, just to do some doodling down here, would be something like x squared minus 1. That factorizes into x plus 1, x subtract 1. So you have the root of the number on the left, and then the root of the number on the right, and then you've got positive and negative. That's because when we multiply it out, we get the x squared term, we get the negative 1 term, but because we've got a negative amount of that and a positive amount of that, they'll cancel out, so we'll have nothing in the middle. So it's kind of a quadratic. Another way of thinking of it is x squared plus 0x subtract 1. That's a lot of explanation, but hopefully it should explain why. We then take the root of the bit on the left. Root 25 is 5. Have a positive and a negative, and then root y squared is y. So 5 plus y, 5 subtract y. Obviously, it doesn't matter which way around you've got them. Finally, I've got a quadratic, so we need two numbers that add to make that, and multiply to make that. So if you forget which way around they are, I like to think of Andy Murray, that charismatic tennis player, because it's add, multiply. It's rubbish, but you know, it's so bad you'll probably remember it. So coming on from that then, I need two numbers that multiply to negative 28. I've used up a lot of my space, I'm going to do it down here. Two numbers that multiply to negative 28. I'm going to think about it that way because there's an infinite number of numbers. Go to positive 3. So 7 and 4 seem the first ones to try. I could have 1, 28, 2 and 14 I could, but let's see. So 7 and negative 4, or negative 7 and 4. I've got there already because I'm going to look at a pair that add to make positive 3, so that top pair do it. But if I hadn't, I'd have then gone and tried 14 and negative 2, or negative 14 and positive 2, and continued on in such a way until I checked all the factors, and you'd always find a pair that work. My pair is that, positive 7, negative 4. Doesn't matter which way around I write them, as long as I get the sign of them right. So x plus 7, positive 7, x subtract 4, negative 4.